Hello, good morning. I am Madhimikilan Salvaraju and I am studying at Polytechnic Sultan Salahuddin Abdul Aziz Shah, and I am from class DEP 3A, and I am going to explain about Internet Protocol Television over Next Generation Network. Nowadays, most of the IPTV services are delivered in a not personalized manner. One end device like a set-top box is represented by one subscriber. Such a coupling of the user with the device limits the personalization and targeting of the exact user behind the device. Therefore, this paper analyzes several aspects related to personalization and single user identification, profiling, and targeting. This personalization requires from the system a full understanding of the context among the device, user, service, and content. This can be achieved only if the system can identify its users, the actual expectations of the next action, and can provide fully adapted user interface presentation, service behavior, correct content recommendation, search and content presentation. Then, what is IPTV revolutionary? Number 1, true interactive television. Number 2, see anything you want to see anytime, anywhere on any devices. Number 3, reduced infrastructure cost. Number 4, IPTV works on your existing internet connection. Number 5, infinite number of channels. So, what's the services offered by IPTV? They've got 4 services offered by IPTV. Number 1, video on demand. Number 2, neo video on demand. Number 3, time shifted TV. Number 4, TV on demand. So, what is video on demand? This service allows its users to order for watching any movie from the VOD server's media library. The subscriber can use the pause and rewind features. Near video on demand. Near video on demand is a pay-per-view video service like VOD but intended for multiple users subscribed on VNVOD service. Subscribers can look through schedules and plan watching the content of interest. Time-shifted TV adds interactive features to TV channels watching. The subscriber can pause the playback at any time and resume it later. TV on demand. TV on demand is the selected TV channels are recorded to be viewed whenever the customer finds more convenient. Moreover, there got 4 roles contained in IPTV. Number 1, content provider. Number 2, service provider. Number 3, network provider. And then customer. So, content provider. The content provider is the owner of the content. It delivers content as streams, files, tapes, and etc. Number 2, service provider. Service provider provides IPTV services. It ingests and protects IPTV content. Number 3, network provider. Network provider delivers streams from service provider to customer. The customer selects and consumes content and pay bills. So, existing NGN based IPTV architectures in the context of personalization. The IPTV service personalization consists of several phases during service delivery to a specified user in a personalized way. Number 1, user equipment startup and user login. Number 2, service subscription and activation. Number 3, service discovery and service selection. Number 4, service initiation and service behavior control. Number 5, services configuration and profile self-configuration. Number 6, converged identity management and service access. Number 7, targeting user preference, recommending services. Number 8, service and media delivery personalized content representation. Number 9. User profiling with service history, collecting service present information. Number 10. Support for personalized IPTV services, content recommendation, personal channels, content bookmarks, and user-generated content. All mentioned aspects follow technical requirements that have to be fulfilled when service providers want to provide fully personalized service. The NGN integrated IPTV architecture. The NGN integrated IPTV subsystem provides basic integration of existing IPTV functions to the NGN architecture and other NGN subsystems, especially with the integration of a user profile server function called UPSF and transport control using resource admission control subsystem. It's called RACS, and network attachment subsystem. It's called NASS. A user can access the service description with his UE via the service discovery and selection function called SD and S that follows DVB IPI specification and uses the hypertext transfer protocol called HTTP or DVB SDNS transport protocol DVB SDP over the TR reference point with limited personalization. The same TR interface can be used by the UE to access the user interface and service selection over customer-facing IPTV application. The customer-facing IPTV application provides an HTTP-based interface over the TR reference point for IPTV service provisioning, selection and authorization with HTTP digest, and also the possibility to identify a user and adapt the user interface or present services. UE can also access common services in NGN via interaction with NGN application. So, the table shows the IPTV functional architecture, NGN functional architecture, and remarks. So guys, you can understand the concept of IPTV functional architecture, NGN functional architecture, and the remarks. And now, I'm going to explain about the NGN IMS based IPTV architecture. The second type of NGN-based IPTV architecture has replaced the IPTV control with an IMS-based subsystem and introduced session-based IPTV service control based on the Session Initiation Protocol. It's called SIP. The IMS-based IPTV has the advantages that IMS concepts may be adapted. An IMS user has one or more public user identities allocated. An IMPU is either a SIP uniform resources identifier, is called URI, or a TEL URI. Each IMS subscriber has assigned at least one private user identity, is called IMPI. IMPIs have the format of a NAI, it's called Network Access Identifier. The IMPI is linked to the user profile, hence it is the key component for a user personalized access to services. The service discovery is performed by a special SIP application server. The service discovery function is called SDF. The SDF provides information about the service selection function called SSF. The SSF contains necessary service information for initiating IPTV services and can be fully personalized based on the IMPI and the user profile. The service control function is called SCF is responsible to serve SIP-based service initiation request from UE delivered over the GM interface via IMS core for any IPTV services. The IMS-based IPTV system has various advantages as the IMS act as unified service control subsystem for all NGN service instead of establishing an additional specialized subsystem. Additionally, the IMS can more naturally support mobility interaction with NGN service enabler. The user profile can be used to store the user's service profile, action data, preference, personalized content bookmarks, and its service history. This and other users' data provide enough information for user profiling. The identification of content and structured metadata is necessary to establish the context between user and the content. So guys, this is the NGN IMS IPTV architecture. Next, personalization of IPTV services in converged NGN-based IPTV. One advantage of converged NGN-based IPTV is the possible interconnection of both existing concepts with external systems like Web 2.0 Internet services, multiple content source and distribution network. The converged NGN-based IPTV can aggregate user profile information and preference from external applications, and combinational and hybrid service are now supported. Next, we are going to see the converged NGN-based IPTV architecture and integrated mechanism for personalization. So guys, this figure shows proposed high-level procedures for the converged NGN-based IPTV architecture including use protocols. Initially, the UE is required to start or boot and perform the network attachment to obtain network parameters. Number 1. After the network attachment, the UE is required to start the service initiation steps including identification and authentication from the user behind the UE. The UE shall perform service discovery from multiple service providers in order to enable SD and S procedures with default service provider. The UE shall perform the service selection procedure with SD and S using HTTPS over TR to receive personalized service selection information with content, metadata, recommendation, and user bookmarks. The UE needs to acquire and use collected service selection information and personalized user data to establish an appropriate attachment to the selected service via IPTV converged application functions called ICAF. With each service request, the present user has to be identified. The identification of the user can be done using the present state user mobile with RFID near to TV set to attachment to home fem toggle in room or user action when the user in front of the TV set changes. ICF can control services behavior via the IPTV service control function. It's called ISCF, whereas both the initiation via SIP and HTTP may be supported. The ICCF is also able to initiate the resources reservation and allocation process for the network resources needed by the IPTV services according to the capabilities of the UE and access network. The ISCF is responsible for personalization of service behavior, performs user profiling, and indicates user preference for the next action. Following a success session initiation, the ISCF informs about identification of selected multimedia content to initiate its delivery. The UE may interactively control the media system. Next, personalizing IPTV services behavior using presence and user profiling. Basic IPTV services and their implementation within the IGN framework can be used for personalization and the presence framework for updating the present state and profiling. Number 1. Broadcast TV, delivery of linearly. The broadcast and or multicast TV channels. It limited possibility to personalize content, but presence and profiling of user action can help understand user preference. Number two, content on demand. It's called COD. It's users request content on demand. Number three, pay per view. It's called PPV. The users pay only for particular show, not whole TV channels or package. Presence could trigger PPV usage. Number 4. Personal video recording. It's called PVR. The users can record content in network or locally in SDB. Presence and user preference could be used for decision where the content is. Basic services usually use presence to observe the actual state of the service. A more advanced concept is required for combination and personalized services where IPTV is combined with interaction, profiling, and targeting. The hierarchical presence model can be used to aggregate information not only by UE updates but also directly from IPTV functional elements. The appropriate utilization of the concept of web-based presence aggregation and relevant correlation of data can allow a combination of presence with IPTV services and enhance the user experience. Examples are combinational services where IPTV services are combined with presence to improve the user's experience due to enhanced interaction, profiling, personalization, or targeting. Advanced IPTV services require a more complex presence state model and correlation of present state with user preference to finally affect service behavior. Number 1. Interactive TV. Service providing interactively between provider and end user or between several users. Presence help to identify currently available users and profile information to suggest types and scenarios of interaction. Interactive application may be provided also by external sources. Number 2. User-generated content. It's called UGC. Content produced by the end user with the intention to share it with others. Distribution of UGC makes sense only to the available party that is willing to receive content. Publicly available UGC can contain much more assets as normal COD offers, especially if made available on the internet. It is therefore important to know user preference and optimize research or presentation of content. Number 3. Content recommendation. Service advisory for favorite shows based on users' preference and previous behavior. Here, presence and profiling is crucial to define the right recommendation hints. If the system fails in identifying the correct content or service proposal for the exact user in the right time, it will dismiss correct recommendations which will be in contradiction with user expectation and real preference. Number 4. Content bookmarks. The users store in profile markers to content and time. Content bookmarks can be used to park a show. It can be picked up on other device based on user authentication. Number 5. Targeted advertising. Advertising mechanism that is targeted to the specified group of users or individual based on their profiles. Together with user profiling and presence, the operator can identify user interest and target type of form or place of advertising. Personalizes channel. User-specific list of programs that are scheduled as playlists for personalized preview. IPTV and NGN service interaction has to be addressed as well as it is individual communication not to be shared with other users on the same device. Next, application in NGN lab for converged NGN based IPTV, non-IMS and IMS IPTV. The NGN lab is a test bed that contains all necessary functions to demonstrate a possible NGN and IPTV interaction within a proof of concept setup of converged NGN-based IPTV. The existing ISIP, IPTV, AS and its respective clients have been extended with the required SIP component and the interaction ASF towards non-IMS IPTV platform. So, this figure shows that action on the side of user A imply actions in both users B SIP UE and user B IPTV UE or STB. The SIP UEs are normal clients that register with the SIP register IMS call or IPTV services control. If user A wants to interact with user B, it is required to send all SIP messages through the SIP or IMS proxy. The testbed uses SIP invite messages for session initiation and SIP message for text interaction. As the SIP proxies are always in the middle of the user's interaction, it was the obvious point to connect the mapping ASF. The SIP proxy is called ISCF will fork SIP requests via the ISC interface to the interaction ASF that can transform SIP to HTTP or XML messages. They can then be forwarded to non-IMS IPTV UE. Next, extended mechanism for personalization by IPTV user data presence and profiling. The profiling and personalization capability that enables personalization of IPTV services based on users' preference and user profile is mandatory to enhance user experience and to differentiate from usual non-NGN IPTV services. The provider can also use the information about the user behavior and content consumption to improve interaction with users and provide the target recommendations by using the user's current, present state and service or content state, service history, user preferences and user content bookmarks and rate button, initiation of recommendation of user indicated or preferences. Generally, in IPTV architecture can exist the hierarchical model of relations between the internal service state of functional elements, the IPTV service state information and presence information, and all this information can be used for users profiling and flexible IPTV services personalization. Number one, the internal service state information can be aggregated in IPTV service state and IPTV service state data can be used to update presence. Number two, IPTV presence may be related also to users action data as well as used for updating the user service access history. Number three, user's profile could be updated from external application. This figure shows that the service state model and user profile with the presence used for IPTV service personalization. So guys, now we are going to see the advantages of IPTV. There are got two advantages of IPTV. Number one, cost effective. Number two, multi-screen access. The cost effective. The cost effective compared to traditional TV, IPTV is inexpensive. With low price, you can have access to all the channels to your cable provider provides and more. Some IPTV providers charge less, but keep in mind that you pretty much get what you pay for. IPTV also gives you access to most international channels that you otherwise would not get in your traditional cable company. And even if you are unsubscribed to international channels, they come at a huge cost to you. With IPTV, you get access to a variety of local and international channels to choose from. Number two, multi-screen access. Unlike traditional cable TV, when you can only access it from your home television, most IPTV providers give you the multi-screen option. With this option, you can watch your favorite shows and movies anytime and anywhere as long as you have internet access. Next, we are going to see the disadvantages of IPTV. So I got the two disadvantages of IPTV, that's occasional buffering and high-speed internet. Occasional buffering. If you are an IPTV subscriber or thinking about ditching your cable company of IPTV, keep in mind that most IPTV comes with some occasional buffering. However, there are some peripheral routine maintenance you can perform to avoid the buffering and have a great experience. High-speed internet. Keep in mind that the heart of the IPTV is solely dependent on your high-speed internet. Hence, to have a better experience overall, you need a good quality dependable internet connection. So guys, from the conclusion, I want to propose some advanced scenarios of IPTV services using existing and extended mechanism for converged NGN based IPTV architecture that provides fully personalized and interactive IPTV services across multiple devices and multiple users that can improve quality of experience and user expectation of personalized IPTV service behavior. So goodbye guys.